All right. So 1, 2, 3. Yeah. So now we need to convert it to per meter width. I need 9, 10 millimeter square, right? So, but we need to tell people, okay, 1 meter width, how many bars you need to use? Okay, how many bars that you need to use? Let's say I use T12, right? I use T12 bars. Area of T12 bars is 113 millimeter square. Okay, so how many bars? Will be 9, 10 divided by 113. So number of T12 bars equal to AS divided by 113. What's that? So this is equal to how many?
8.05.
Huh?
8.05.
8.05. So 8.05 number. Okay. So now you can either use 9 or 8 because 8 the percentage difference is 8.05 is only 1% difference. So we use 8. Let's say we use 8. So if we use 8, then we have to see, okay, 8 number of bars per meter. So what's the spacing? It will be 1000 divided by 8, right? So 125. Correct? So that means we are using T12 at 125 millimeter. Understand? Okay. So so the spacing is equal to 1000 divided by 8. Understand? Or you can say divide 0. This one. Divided by 8, 5. So 124.22, right? So 124.22. So here is 124.22. You either round it up to 125 or 120. Okay? Understand? Then that's it. Okay? So this one, okay, alright now. Okay? So so now the pre-stress one, I think you need to pass back your test 2 rework to me. Either you tonight you go and work on it, or tomorrow you pass it after your one. Now I want to talk about the shear wall. Okay, at least you can work out the first part. Is that okay? All right. Can you rub this one off for me? Then. Okay, so after you finish the shear wall, then we will dismiss, and then you go and study for your final exam for the afternoon. Okay. Okay. First of all, the shear wall. We have 3 load cases, right? 1.2 dead load, live load, wind load, or 1.4, and so forth, right? So I just tell you that in the exam, you are going to work with a 1.2 dead load, live load, and wind load. Okay, understand? Okay, load cases are. Load cases. We have three. First one is 1.2 for everything. Dead load plus live load plus wind load. Then the second one is 1.4 dead load plus I think 1.4 wind load. Then the third one is 1.0 dead load plus 1.4 wind load. Okay? So normally you have to look at these three, but in the final exam, I ask you to look at only one load case. This is the simplest. It's 1.2 apply to everything, right? Okay. All right. Okay. So the first thing that you will see is I give you a plan. Let's say a plan, and there are two walls here. Thickness are different, and then length is different, right? Okay. So this is a plan, and then the wall. This is the slab, right? This is the wall. Okay. So this is wall 1. This is wall 2, and this is the floor slab. Okay. This is a plan. Okay. First, our final goal. Wall shear wall design. First is to get the PU and the MU. Okay. So the shear wall, let's say this is the shear wall. Okay, I need to get the PU at the base, okay, and then the MU at the base. Okay? Okay. This one, from here you do the PU over BH, which is the axial stress. Okay? And this one is MU over BH squared. Okay? Now which one is B? This is B. This is the B. Okay? And this one is H. Okay? Alright? That means we are looking at this cross section. We are not looking at this cross section, we are not looking at this area, we are looking at this area. Okay? So this is pH. Then you would you will be given this chart. This chart, this chart, you have the x-axis and the y-axis. How do you use this chart? This one here is N over BH, axial stress. Okay, this is bending stress. So here, this is axial stress. Axial stress is just the force divided by the area. Understand? The force divided by area. The bending stress is BH squared. Okay? This is the bending stress. This is axial stress. So, axial stress is this one. Here, 5 MPa, 10 MPa, 15 MPa, 25, 20, 25 MPa. Here, this is the bending stress, M over BH squared. Bending stress is 1, 2, 3, 4, 5. Okay? Let's say what you calculated is, here is 15 MPa, bending stress. Let's say, argument's sake, let's say this one is 15 MPa, and this one is 2 MPa. Okay? Alright? Let's say this one is 50 MPa, this is 2 MPa. So 50 MPa is here, 2 MPa is here, right? Then you 2 come up here to 15, right? So it's somewhere here. So this is 0.4, this is 1. So this is somewhere in the middle, right? So what is the value in the middle? 0.7, right? So here 2, 15 is 0.7. So 0.7 of what is AS over BH. So here from the charts, so from the charts we come to AS over BH is equal to 0.7% of steel. Understand? That means this is 0.7. That means 0.7%. Okay. Well, let me rewrite this out. That means AS over BH multiplied by 100 equal to 0.7, right? Correct. And you move this over here, becomes AS over BH 0.7 divided by 100, right? So 0.7 divided by 100 is 0.7%, correct? Understand? Huh? Okay. 1% is 1 over 100, correct? 2% is 2 over 100. Okay. Percent actually, we say percent, right? Okay. Percent actually coming from 2 words. Per century. 1 century is 100 years. So percent is per 100. Okay. So that's why 0.7 per 100 is 0.7%. Then we need to find AS. Correct? You need to find AS. So then your AS will be equal to 0.7 100 multiplied by BH. Okay? Then we give you the AS. That means the amount of rebar that you need to put. So this is the total, right? Normally in shear wall, we will have 2 rows, 1 on each face. So what you find is this AS, you divide it by 2. That means each row, how many? Understand? Okay? Right? Let's say this one is, okay. This is total, so this is per row, right? Per row. And then you have to divide it by this length. That means each row, each meter, then you convert it to the number of bars. Because eventually we need to tell people, is it a T12 at 200, T12 at 100 per face, per row. Understand? Okay. So if this is given to you over here, then this is very easy, right? At least you can get to here first. Whether you can know how to convert it, that's a different matter, but at least you already get most of the marks. You see what I'm saying? Okay? Now, let's bearing in mind shear wall design, you need to get the PU and the MU here. Okay, P and MU. So once you get this, you have axial stress, bending stress, then you go to the charts and so forth. Okay, so the question is, how do I get PU and MU? So PU is the axial load due to gravity, right? Due to gravity, because so here, calculation of PU, okay, at the base, at the base. Because the base is the most critical, right? So we calculate at the base, So calculation of PU at the base, this is due to gravity load. PU, that means axial PU at the base due to gravity load, right? So what's the source of gravity load? So first of all is the wall self-weight. Okay, the wall self-weight. So wall self-weight is equal to concrete, because it's made of concrete, right? So kilonewton per meter cube multiplied by the volume of the wall. So volume of the wall is what? First, you calculate the cross-section area multiplied by the height. Understand? Okay, that is a volume. Okay, understand? Volume is cross-section multiplied by the height. So the height, this height could be 50 meters, because you can talking about 20 story, 30 story, right? So the height can be quite big. Okay, thickness maybe 300, 200. Okay, normally wall thickness. Okay, wall thickness normally, typically 200 to 300. Okay, but then if it is higher, then it becomes 400, 450 and so forth, right? So this is 200, 300 typically. This length, okay, this length here, okay, could be 2 meter, 3 meter. Okay, so typically is 2 meter to 3 meter. The height will be in the tens, 20, 30, 40. Because depends on how big this will. Understand? So based on that, based on the 24 kilonewtons per meter volume, you get the entire self-weight of the wall, right? Of the wall. Now, okay. So this one will give you the P of wall. P of wall. Okay? Understand? This self-weight of wall, P of wall. So here is a P of wall, right? It's equal to 24 kilonewtons multiplied by the volume of wall. Okay? Then we have, because the wall is carrying the slab, so we also have the loading from the slab. Okay? Loading from the slab. Okay? Alright? Understand? Just like, let's say this is, so this is the wall. This is the wall. This is the wall. So they have the self-weight, right? Then I also have the slab sitting on the wall, right? So that is why the slab loading has to be transferred to the wall. So you need to account for that. Understand? So that is why the second item is loading from the slab. So loading from the slab has two types. One is the dead load plus superimposed dead load, and then B is the live load. Okay. The dead load plus superimposed live load is include this value will be given to you. Okay. They include the self-weight of the slab and the superimposed dead load on the slab. Okay. Okay, understand? Huh? Okay. And then we have the superimposed live load, people walking on the slab and so forth. Right? Superimposed dead load will be let's say your tilings, which is not going to move, your ceiling, which is not going to move. Okay, so here normally this will be given to you in area load. Let's say this is 2.0 kilonewton kPa, kilonewton per meter square, and let's say this is 0.6.0 kPa. Understand? This is kPa, meaning is area load, kilonewton per meter square. So I give you the area load. So you need to find the load. Let's say here, let's say I give you 20 meter. Let's say this, and this one is 10 meter, right? 10 meter. So the total slab area will be 200 meters square. So half of it go to here, right? The other half go to here, right? So the loading, so here I need to PSDL and PSLL. Okay, alright. So here you start from the area load. So you start from the area load. Area load. This is all area load. Then you need to convert it to the total load, right? So from area load to total load is what? That means you need to multiply this with the area, correct? So this wall is supporting 10 by 10, right? This is 20, so half of it is 10. This is 10, right? So this wall is supporting a 10 by 10 area, correct? That means it's 100 meters square, correct? So what you do is, in this case, this is the example, is 6.0 kPa multiplied by area. I say supporting area. Okay? Alright, let's say supporting area in this case is 100 meter square. This is kilonewton per meter square. So this will be 600 kilonewton, right? 600 kilonewton. Right? So this is easy, right? You start from the area load, multiply by area, you get the load, right? Okay, follow up, follow up. Just want to make sure one of you follow, then you can, the others you can bring in. Now, this one is loading from the slab. So this 600 kilonewton, this 600 newton is 600 kilonewton at each floor, right now? At each floor. So here you have, let's see, so this is the wall, let's say, these are the levels. Okay, so now you have this P DL plus SDL, and also we have PSLL, right? At each floor. Okay. Then you have to multiply the number of floors, because I will also give you an elevation view telling you how many floors are there. Let's say 15 stories. Then you multiply by 15. Understand? Okay. So here, let me off the lights. This one here, okay. This one here Now, for those of you, what I'm saying is we have talked about three, right? Pre-stressed concrete, retaining wall, earth retaining wall, and torsion, right? If you don't want to remember too much, you just remember these three first, okay? If you think that you can handle extra, then you do this. Understand? I just don't want to overload you with too much information. Okay? All right? Okay. So this part here is loading from the floor. So this is kilonewton. Per floor, right? And then this one is 200 kilonewton per floor. Then you have the PSDL or SDL or DL lah, DL plus SDL lah. Then you say at base, summation, right, is equal to 600 kilonewton per floor. Let's say I have 20 floors, right? 20 floors. Then there will be 12,000 kilonewton, right, at base. Okay. Then the same thing. Summation of P SLL, right, is equal to 200 kilonewton per floor multiplied by 20 floors. Okay, but this could be 30 floors, 15 floors, 10 floors. Then you have to look at the what okay. Then this should be 4,000 kilonewton at base. Right? Okay. Now, then I have to do the PU. So the PU is equal to load factor 1.2, right? P wall plus BP superimpose that load plus that load. Here I should do a summation of P dead load plus summation of P I. Understand? Okay. P wall is wall self weight, which is the gamma's, the unit weight multiplied by volume of the wall. Okay. Here you need to do a summation of P dead load because you start from each level. Right, so you have to summation. That means you have to plus all the levels together. So here you start with loading from the slab, area load, live load, area load, dead load, and superimposed area load. You will be given to you, right? Then the loading will be area load multiplied by the supporting area. Supporting area, look at the plan. Okay, this could be 15, this could be 12, depends. Okay, all right. Then you get the PU. Okay? Follow on. Okay. Now, so this one is easier. This one is a little bit easier. This one is a bit easier. Okay. Then I need to. So here, calculate our axial PU at the base due to gravity load. Due to gravity load. Then now I need to do the calculation of MU due to the wind loading. Okay, alright. This one is coming from the gravity load. This coming from moment is coming from the lateral wind loading. Okay, lateral wind loading. Due to wind lateral wind loading. Now, the vertical wind loading, okay, normally I give you, there are two walls here, right? There are two walls. So now, look at the plan view, I look at the elevation. So these are the connecting slab. These are the two walls. Let's say this is wall 1, this is wall 2. Okay? Then I have the wind load. Let's say this could be 50 kilonewton per meter. Let's say, okay? Then it is the wind loading, right? Wind loading, okay? You have to distribute the two walls, okay? Now the area, the vertical load is you distribute it to based on the supporting area of the wall, right? This one we have to distribute it based on the stiffness of the wall, okay? All right? And the stiffness of the wall, so you have to first calculate the K1 stiffness of wall. Okay, because the first you calculate K1, the stiffness of wall. K1 stiffness is equal to B1 H1 cube. Okay. Then K2 will be B2 H2 cube. Okay. Then we have to do the distribution factor to wall 1, which is K1 divided by K1 plus K2. Okay. And this one is distribution factor 2 is K2 divided by K1 plus K2. So if the two walls are equal, that means 50%, 50% distribution. Okay, if one wall is bigger than the other, let's say these two walls. Let's say these two walls have the same length but different thickness. Okay, let's say this is 200, this is 300, right? Then that means if they have the same length, that means this H1 cube is equal to H2 cube, right? Right? Then the only thing difference is B1 and B2. Okay, B1 and B2. Then in that case, this will be one will be, let's say it's 200 and 300, right? One will be 40%, the other one will be 60%. So you go and calculate it. Understand? Okay? Alright. So this could be 0.4, 0.6, or 0.5, 0.5. Okay? Then you distribute 15 kilonewton based on the percentage to each wall. So now you have, let's say I ask you to design, let's say just one wall only, wall 1 or wall 2. Okay? Let's say I ask you to design wall 1. Wall 1. Then let's say this is a 15 kilonewton per meter. Let's say wall 1 receive 40%. So you multiply by 0.4. Get this one. This will be equal to 6 kilonewton per meter. Right? That means this wall, so what is the moment? Moment is equal to, let's say this is W, right? W. So it will be WL squared over 2, cantilever moment. Understand? And then MU will be equal to 1.2 times M. So that's how you got this one. Okay? Alright. So let me summarize. This one PU coming from the gravity load. MU coming from the wind load. Now gravity load, I think is easier for you to calculate, right? So the gravity load, PU, is 1.2 coming from the wall itself. The loading from the slab, loading also live load from the slab. Here I use summation because it comes from each level. Okay, understand? So each level you add them up, get the PU, and the MU is due to the wind loading on the wall. Okay, the total wind loading is 15 kilonewton per meter. A certain percentage you go to wall 1, certain percentage you go to wall 2. Okay, then how do you calculate the percentage? Is first you have to calculate K1, K2 first. Okay, so let's make things. I couldn't remember what's the size of the wall, but let's say H1 is equal to H2, right? So what you have is distribution factor 1 is equal to K1. K1 is B1 H cube. I say H1, H2 is the same, though I just use H. Then here will be B2 H cube, B1 H cube plus B2 H cube, right? And then H cube is the common factor. B1 divided by B1 plus B2. This cancel, right? Okay, let's say one is 200, the other one is 300. So 200 divided by 500, right? 200 divided by 500 will be 0.4. The other one will be 0.6. Understand? Okay, once you get this one, then now I think this part is a little bit difficult, because you haven't done enough of it. Okay, so but for this problem, try to get as many marks as you can. That means, let's say you finish this portion here, maybe you get 50% of the marks. Then you get, and so forth. Understand what I'm saying? Even though you get this one wrong, but at least you go through it, I still give you marks. Understand or not? So I know that this problem is kind of a last minute thing. I don't expect you to remember it. So if you cannot remember so much, just concentrate on the three that I'll talk about. Okay, if you are comfortable with it, then this one you just try your best. Okay? Alright, so best wishes to you on your test, your final exam. Alright, okay. Alright, now you go, I think almost 11 now, right? So have your lunch and study for your final exam.